So the second design factor that we're going to talk about is active material. So active material is what is pasted onto the grid. That active material is either more or less dense in terms of grams of active material per amp hour of capacity that we want that battery to produce. It's pasted onto flat plates, or it's inserted into the tubular gauntlets of tubular grids. And then finally, it's cured and formed or converted or optimized for varying degrees of performance and life. In the industry, we call that alpha versus beta, or cycling capability and life versus initial capacity and starting power. So just as the grid design determines a battery's cold cranking ability, the active material on the positive plate and the negative plate will determine a battery's capacity. So its capacity in amp hour or reserve capacity and its overall cycle life. So more active material plus higher density active material equals more capacity and amp hour. And increased cycle life. So back to the concrete analogy, active material for batteries or active material design and application is just as important to a battery's performance and life as it is to concrete. So in concrete, we use aggregates, different sized aggregates. We use additives. If it's in a very flexible structure, we'll even put fiberglass particles into that concrete to give that concrete more flexibility. Well, we do the same thing in a battery design. So in the active material design, we have what we call expanders, all kinds of secret sauce that we stick into that active material to help us achieve the life or performance that we want to get out of that battery. So depending upon the performance requirement and the end-of-life characteristics that we're trying to get out of that battery, the active material that we're pasting onto those grids, just like the concrete mixture, will be either more or less dense, and that means drier or wetter, and it'll be harder or easy to apply to the grid. So once again, if you're trying to produce 250 or 60 meters of plates a minute, you're really not going to be able to apply real dense active material to those grids. Just like in a concrete structure, if you're building a concrete structure that has really dense concrete, you're going to have to use vibrators to get into that concrete, to vibrate that concrete down. So obviously you're going to pour less concrete over the same period of time than if you were using a wet or less dense concrete, or a concrete mixture that was less complicated or had less chemical additives or less expanding elements in the active material.